What's up, everybody? All right, we're moving on to chapter 6 now, in which we're going to be dealing with similar figures as opposed to congruent figures, which is what a lot of our previous studies have been about so far in geometry. And in this section, first section of the chapter, we're going to be learning about ratios, proportions, and means, as you can see. The first of those two things, ratios and proportions, you should be familiar with. The geometric means, probably a brand new idea for you. Going to do this in two videos. The first one will focus on the first two, the ratios and proportions, in which the goal will be for you to find unknown values in proportions, which you probably know how to do already. However, despite that fact, it's worth your time to watch this video because there's lots of information that you don't know about proportions likely that I will cover with you. Okay? So let's get right on to that then. Proportions, ratios, those types of things. And what I'd like to do, of course, is start off with a geometry aspect to this. I've got a couple of figures that are similar, triangles that are similar to one another. I told you that we would have a chapter here about similar figures. All right, so let's work with them now. But the focus really here is not on the similar figures. It's just on the fact that I'm trying to teach you how to make ratios. And I'm trying to get you to write the following ratios in simplest form. Now, there's a couple ways that you can write ratios, as I know that you're aware. One way to write a ratio is just by the same format that I've got these written in, basically. You can say the ratio of A to B equals the ratio of B to C, correct? Or you can also write them in fraction form. I'm going to write them in this form right here for this example. The ratio of AB to BC means make a ratio between the length, from the distance from A to B and the distance from A to C, which in this case then would be 18 to 30. Now the reason I mentioned the alternate form thing is because I want you to know how you simplify a ratio. You simplify a ratio the way you would simplify a fraction, and that's by finding a common factor for the two numbers within the ratio. 18 and 30 both divisible by 6, and so I can simplify that to 3 to 5. All right, and then let's do the same with the next couple pairs of ratios. Want to do this twice more because there's a point that I want to make, not because I don't think you already don't have this already. The ratio of AC to DF is a ratio between the bottom side of this triangle and the bottom side of this triangle, and that's 30 to 45. And the common factor for 30 and 45 is 15, right? So that becomes a 2 to 3 ratio. Now you ought to observe something after this next ratio that I want to talk about. BC to EF. Now it's the ratio of the right side of this triangle to the corresponding right side of this triangle. BC is to EF as 22 is to 33. 22 and 33 are both divisible by 11, right? And so that gives you 2 to 3. And the observation I was referring to is that those last two ratios are equal. In fact, I told you that these triangles are similar to one another, and the way you can determine whether two triangles are similar, or a way, is to see, do all the pairs of corresponding sides have the same ratio? Well, 30 to 45 is 2 to 3, 22 to 33 is also 2 to 3, so is 18 to 27, it turns out. All right, but here's really the point that I wanted to make. We're talking about ratios and proportions, and I want you to know what a proportion is. And what a proportion is two ratios that are equal to one another. A proportion is an equation between two equal ratios, we said. All right, so that's written down. You ought to write that down as well. And so an example of a proportion would be that 30 to 45 equals 22 to 33. That is a proportion. And that's just because 30 to 45 is a 2 to 3 ratio, 22 to 33 is exactly the same value when you simplify it, so we know those two ratios are equal. Great. Now you know what a proportion is. That's one of the things I wanted to make sure I taught you here. They don't always have to have variables. You're used to seeing variables within a proportion. It just has to be two ratios that are equal to one another. All right, now building on that fact and to teach us something additionally about proportions, I've given you a ratio of 4 to 7 and I want us to write two ratios that are equal to that ratio of 4 to 7. And then we're going to work with cross products and show that the cross products of the related proportions are equal to one another. Well, let's first come up with a couple of different ratios that are equal to that ratio 4 to 7. And if you're looking for ratios that are equal to another ratio, the simplest way maybe of making that is just simply multiply both numbers in that ratio by the same scale factor, so to speak. So for instance, I could multiply 4 and 7 both by 2, and I could get a new ratio that's equal to 8 to 7, 4 to 7. 8 to 14 is also the same as 4 to 7. And I could have picked any scale factor I wanted to and multiply both 4 and 7 by that scale factor and come up with a proportion. Let's say we multiply them both by 4. 4 times 4 is 16. 7 times 4 is 28. The ratio 16 to 28 is also equal to 8 to 14, isn't it? All right, now let's get to that cross products thing I was talking about. I can make proportions, 3 proportions out of the 3 ratios that we've written down just by picking any 2 of them and making an equation with them. So I can make it a ratio, for instance, a proportion 4 is to 7 as 8 is to 14. And now there's a special property about proportions that I want to illustrate right now. Whenever you have proportions, the highest and the lowest number, in this case the 4 and the 14, are referred to as the extreme values in that proportion. The extremes, that's a term you ought to be familiar with in regards to proportions. And then the 2 values that are in the middle, or not the highest and lowest, but between the highest and lowest values, are called the means of that proportion. So 7 and 8 are the means here. And it turns out that in every proportion, the product of the extremes, which in this case would be 4 times 14, is always going to be equal to the product of the means of that proportion, in this case 7 times 8. And you can see that 4 times 14 is equal to 56, and that 7 times 8 is equal to 56. So there's an illustration that the product of the extremes equals the product of the means in a proportion. And just to illustrate that that happens that way every time, let's just make the other proportions that we can using the 3 ratios that we wrote down. For instance, I can make a proportion that says 4 is to 7 as 16 is to 28. And then we'll show that the cross products are equal. That would be 4 times 28 equals 16 times 7. And both of those cross products are equal to 112, so you can see that that's true. The last proportion that we can make using these ratios would be 8 is to 14, as 16 is to 28, set those 2 ratios equal to one another. And then show that their cross products are equal. And that would be showing that 8 times 28 equals 14 times 16. And each of those are equal to 224. All right, now I went through that to talk about this. You guys are used to using cross multiplication to solve proportions. And the reason that cross multiplying works is because the product of the extremes always equals the product of the means if you actually have 2 ratios that are equal to one another. Now let's take advantage of that fact to solve some proportions. Here's what you're used to seeing. The way we're going to solve this proportion for this unknown value r is we're going to use the fact that the product of the extremes, r plus 7 times 5, has to be equal to the product of the means, 3 times r. We've just illustrated that, so it should make sense to you. So you set those cross products equal to one another, and then you distribute whenever you multiply a monomial times a binomial, of course. So you get 5r plus 35 equals 3r. So then 2r equals negative 35. R then would be negative 17.5 or negative 35 halves if you leave it as an improper fraction, which is of course completely acceptable. Okay, so cross multiplying is how you solve proportions, and you know why it works now. Let's do that again one more time, but in the context of a geometry question. Here I've told you that the ratio between QR and RS is 4 to 5, and I want you to use that fact to find the value of R. Well, first let's write a proportion. If we know the ratio between QR and RS is 4 to 5, that means we know that those two things are equal to one another, writing it in a proportion form. And then we can simply substitute The distance for QR is 32. The distance for RS is 4R plus 6. Set that equal to 4 over 5. See if you can pause the video right now and solve that proportion. No doubt that you can. And then just unpause in a moment to see that you got it right. Okay, there's the cross products. Always set the cross products equal to one another. Don't make a new fraction that says that that's written 32 times 5 over 4 times 4R plus 6. I see so many people make a new fraction here. Set them equal to one another. And here you're going to get that 160 equals 16R plus 36. Or excuse me, plus 24. So then 136 equals 16R. And then you should have gotten that R is equal to 8.5 if you wrote it as a decimal. If you wrote it as an improper fraction, then it would have been 17 over 2. All right, guys, that's ratios and proportions. Thanks for watching. Make sure you see the next video from this section about geometric means. Later.